Screen is
Yes,
visible
sir.
to you? Now here, where is the bond is cleaving? Here, OH bond is cleaving. Now in the place of hydrogen, we got sodium. That is called sodium alkoxide, like this. Here also the bond is cleaving here. In the place that one we get the aluminum. And here also the bond is cleaving. In that place we are going to get the sodium. Sodium phenoxide, very, very important one, this one, sodium phenoxide. So these are all acidic properties here. Okay, not only with sodium, we can do with NaOH also because it is acid, weak acid, and this one is a base. So neutralization reaction takes place, and here also what happens? Which bond will cleave here? OH bond is cleaving. So this OH bond cleavage explains the acidic character, isn't it? Acidic character of what actually alcohols, isn't it? For example, if you observe what happens, if I take any base here, for this one I have to take a base here. Now this base will accept the H plus. That is the reason this bond is getting broken and shifting towards what? Oxygen. So that is the reason the oxygen is getting here what? Negative characters here. O minus. Here also what happened? O minus. Here also what happened? O minus. And here also what happened? O minus actually, isn't it? So in this case what happened? The acidic character, if you observe what happened, the primary alcohols which are what happened more acidic, and tertiary alcohols are very less acidic. What is the reason behind this one? The plus side groups here. So here what actually you're having, how many plus side groups are there here? 3 plus side groups are there. So plus in the 11th class you have studied plus side group always inversely proportional to what? Acidic character. More plus side groups, less acidic character. Why? Because in this case what is happening if you observe? CH3OH. So after releasing H plus, what we get? O minus. Correct or not? So let me see this one in the PPT now. Now here, the reaction involving in the OH bond, the reaction involving in the CO bond. So we are discussing now this point actually here, OH bond cleavage. Correct or not? We are discussing actually what? OH cleavage actually. See, this bond we are cleaving actually. When you break this bond, what happened? The bond will shift towards which direction? On oxygen side here. So when you break the OH bond, the bond will be shifted towards where? Oxygen side. This point you need to remember. When you break the OH bond, the bonding electron, the 2 electrons will shift towards oxygen because oxygen is having more electronegativity. In that case, the reactivity will have primary, secondary, tertiary is the reactivity. Now in the other case, what happened? Opposite, that we'll discuss later, no problem. Okay. Now you have seen what happened here. Just now I had given the examples in your textbook. Let me see. Now this one if you observe. I have taken a metal, sodium metal I have taken. Now which bond is cleaved here? OH bond is cleaved and the bonding electrons are moved towards what? Oxygen. So you are getting O minus here. Now this Na will comes here with loss of 1 electron. Will you get like this? What I'm saying here, when you add sodium into alcohol, which gas is liberating here? Hydrogen. So I will explain the beautiful way like this. ROH. Okay. Now this is the bonding electrons are shifted towards oxygen. So what we are getting here? RO minus H plus. Yes. Next. Sodium losing 1 electron, converting into Na plus 1 electron like this. Correct. Next, H plus, this H plus. Take this electron and convert into half hydrogen gas. Half hydrogen gas. And this Na plus and these two combine together, RO minus and what? Na plus, they combine together to give what? RO Na, sodium alkoxide. Sodium alkoxides are forming. Sodium alkoxide. Alkoxides are forming. If it is methyl group, sodium methoxide. If it is ethyl group, sodium ethoxide. Like that we can give it. So this liberation of hydrogen gas indicating that alcohols are having acidic character here. Correct? Next. If I take what? Aluminium, same thing is happening. You just observe the textbook here. Aluminium. But aluminium plus 3, no? 3 electrons, no? That is the reason what happened. I have to double this. Actually, 3 aluminium, if you take what happened, we get 3 by 2 hydrogen. If I take only one aluminum, sorry, if I take one aluminum, we get 3 by 2 hydrogen. So they multiply this one with 2, no problem. So whatever it may be, what happened, you will get aluminum, tertiary butyl aluminum oxide you are going to get, isn't it? Acidic character, what happened? I told you just now. Plus psi groups. Okay, plus mesomeric effect groups, electron donating groups, electron releasing groups. These type of electron donating groups will decrease the acidic character. Based on that, what happened if you observe primary alcohol, secondary alcohol, tertiary alcohol, isn't it? These are the tertiary alcohols. Which is having highest one? Primary alcohols are having more acidic character here, isn't it? This is very, very important for us. What is the reason? Because of presence of donating groups. If you observe what happened, RCS3OH, releasing H plus is called acidic character, correct or not? O minus and H plus. Releasing H plus is nothing but acidic character. Any substance which releases H plus come acidic character. The substance is releasing H plus, therefore is correct. Now what I am doing here in this case, now already electron excess are there, excess of electrons are there here, correct? Because the negative charge is there, excess of electrons are there. Now this group is what actually? Plus psi group. Now plus psi group is also donating electron. Already is unstable because of excess of electron. Now again you are donating these plus psi groups here. Because of this plus psi groups, what happened? Further electron density increasing on oxygen. That is the reason what happened. To increase acidic character, we should now not having plus psi groups. We should have what? Withdrawing groups. So presence of withdrawing groups will increase as what? Acidic character. ये सारी चीज आपको जरूरत नहीं है, मगर सिंपली आपको याद रखना है क्या है? Simple thing. Electron donating groups or electron releasing groups will increase the decreases the acidic character. Correct? So based on this, what happened? The order will be what? Like this here. CH3OH, CS3OH. Next, what happens? CS3, CH2OH. Like this also we can write. Otherwise, what happened? CS3, CH, CS3OH. Finally, what happens? CS3, CS3, and what happens? CS3 and OH. Now here, the acidic character, what happened here? Decreases here. Understood this topic? Any doubts you're having in this one? Any doubts you're having?
No, sir.
Right. Next, you see the acidity of phenols here. Now, if I write something, what happened here? Shall we take this again? We'll come again to this one. Right? Now, generally, what happened in this way? Actually, a base will attract the H plus. Now, I will explain this one. This topic actually here. Now, what is the thing actually? If you observe, alcohols are weak acids than water. So when you compare water, water is more acidic than the alcohol, except one thing. So CH, आप notebook में लिखो बेटा ये CH3OH is a very very important. Water, H2O. Then finally what happened? Any alcohol you can write. Now what you observe between these two? Water is more acidic than the alcohol, but water is less acidic than the methanol. So methanol is stronger acid than the water. This is exception case. So when you read this statement here, alcohols are however weaker acids than water, okay, except what happened? Methanol. Yes. Now what is the reason behind this one? If you observe here, I have taken here alcohol. I am writing here alcohol. ROH I am writing. Is it visible for you? Whatever I am writing is visible?
Yes, sir.
Right.
Yes, sir.
After this one, if it is, for example, just imagine better, this is acid. Just imagine this is acid. And this one, if it is acid, it will be definitely what happened? Base only, right? Now after the formation.
Yes, sir.
After the formation of this product, what happened? Acid will release the H plus. So we get RO minus. and this base will accept the proton, we get H3O plus. H3O plus actually. Okay. Now what happens if you observe here? Now RO minus you got here as a product here. After this, if it is acting as acid. Now reversely, if I take what happened? ROH, isn't it? Reacting with what again? Water. Now you are getting, if you treat this one as a base, this one as acid. Now in this case, what happened? ROH2 plus, and you are going to get the OH minus. Okay. So among these two, if you add these two, this will be happy. This is happening actually. This is happening, and this is not happening actually. That means if you treat water and alcohol, water is acting as acid, and base alcohols are acting as a base. Why? Because whichever is having more acidic character, that will act as acid. Whichever is having less acidic character will act as a basic character. So reason behind this one, if you observe here what happened, if you observe this reaction here, RO minus, this RO minus is a proton acceptor, highly reactive, accept the proton compared to the OH minus, isn't it? Which is stable. OH minus is stable. This part is stable. This part is very stable actually. So the forward reaction takes place continuously. But this RO minus, this part is highly unstable, again accept the proton from H3O plus, and the backward reaction takes place. The backward reaction readily takes place. That is the reason what happened. You see, this reaction will take place. So alcohols, however, what happened, having weaker acid than the water actually. So this reaction shows that water is a best proton donor. See, now here in this case, which is donating the proton? Water, acid. So proton donor is what? Water. Therefore, water is strong acid than the alcohol. So आपको क्या लिखना है? Reason अगर पूछे तो ये सारे लिखने की जरूरत नहीं. आपको क्या लिखना है? This one. Water is the best proton donor. Here, water is a best proton donor. Therefore, it is a stronger acid than the alcohol. Okay. Now you observe this one also. You can alkoxide ion is a better product acceptor. See यहाँ पर मैंने लिखा ना RO minus, best proton acceptor. The backward reaction is taking place. So यहाँ ये भी आपको लिख सकते हैं, best proton acceptor, then hydroxide. So which suggests that alkoxides are strong bases, isn't it? So then compare with what remaining actually. ये आपको याद रखना है. तो आपको क्या लिखना है यहाँ पर? Water H2O is the best proton donor, and whereas RO minus is what? Proton acceptor. This is the thing. But exception, I told you, CS3OH, in which what happened, CS3O minus is what actually not very good proton acceptor. The nucleophile cannot accept like this. So that is a different here. It is not mentioned, but anyhow, you have to remember that. So this will be the order better. This will be the order. It is not given here, but no problem. CS3OH. Okay. Now let me move to what? Acidity of phenols here. Acidity of phenols. Now if I write what happened, alcohols are more acidic than what happened, are less acidic than what happened, phenols. Then this will be the correct. Alcohols are less acidic than the phenol. I can also write like this also. Alcohol less acidic than the water, and water is less acidic than the phenol. Okay. Now let me see. In examination, you may get some question here, 2 marks question. Why phenol is more acidic than the alcohol? What is the reason behind this one? What is the reason behind this one? Why the phenols are more acidic? Now you observe here what happened. I have taken alcohol here. Is it alcohol or not? Tell me better. Is it called alcohol or not? This red part I am underlined.
Yes.
Yes, sir.
Now, when alcohol lose proton, we get alkoxide. Correct or not? We get alkoxide. Correct or not? Now
Yes,
this
sir.
can form resonance. Is it possible? Resonance is possible here. In this case, is resonance is possible? What I am writing, is it visible to you? I am writing whatever.
Yes, sir, it is
Yes, sir.
visible.
Now, but
Yes, sir.
after, now if you observe phenol, if you observe the phenol, when it is releases the H plus ion, when it releases H plus ion, is it possible resonance here? Resonance is possible here. तो आपको एग्जाम में क्या लिखना है? Alcohols are less acidic than the phenol because in alcohol, the formed alkoxide cannot form resonance structures, but in phenol, the formed phenoxide, this one, phenoxide, will form resonance structures. Because of resonance, what happened is stable. This is stable, and the backward reaction cannot take place. If it is stable, backward reaction, what happened here? Cannot be takes place. But it's highly unstable. Why unstable it is? No resonance. So according to 11th class, whichever having resonance structures are stable. So unstable, which reaction takes place here, beta? Backward reaction takes place. So in this case, what happened here? Backward reaction takes place. Here it is what? Backward reaction is taking place. The dominating factor is what here? Backward reaction is. The dominating is backward. In this case, the dominating factor is what actually? Forward reaction. So this is not taking place. This one is taking place. In this case, what happened? This is taking place, and this is what? Dominating actually. So these are the resonance. If you observe what happened, this is the resonance structures. Because of the resonance, what happened? You are getting like this. So ये resonance structures आपको practice करना है. You have to practice. यहाँ पर आपको मैं underline करता हूँ यहाँ पर. Phenol is having acidic character. Okay. Now, what is the reason behind this one? Because of charge distribution in phenol molecule. Because of this, what? Charge distribution. The negative charge, what happened? Distributing between the carbon atoms and depicted in resonance structures. Because of the resonance structures. So, whichever is aromatic ring, whichever is having aromatic ring, they can form resonance structures, and they exhibit what actually? More acidic characters actually. Now here, what is the reason? Double bond character you are having, therefore you are having sp2 hybridization. In this case, it is sp3. In this case, it is sp2. So sp2 can form easily what happened? Resonance structures. Now we get a partial double bond character, OH bond. सारी चीज आपको जरूरत नहीं है. चार्ज इज डिलोकलाइज्ड. ये पॉइंट जो मैं अंडरलाइन करता हूं ना, वो आपको एग्जाम में लिखना है. डिलोकलाइजेशन ऑफ नेगेटिव, ये कीवर्ड्स हैं. एक कीवर्ड्स आप यूज करके एग्जाम में लिख सकते हैं. जो कीवर्ड्स मैंने अंडरलाइन कर रहा है ना, आप नोटबुक में टेक्स्ट बुक में भी अंडरलाइन कीजिए. इन ऑक्साइड इज मोर स्टेबल. व्यवस्था एनालाइजेशन ऑफ फिनोल. सो दीज आर द रेजोनेंस. ये आपको लिखना है, ये एग्जाम में लिखना है ना? करेक्ट. सो दिस इज अबाउट द वाई फिनोल्स आर. तो आपको क्या लिखते हैं एग्जाम में? वाई फिनोल्स आर मोर एसिडिक देन द अल्कोहल्स. Phenoxide ion which is formed can be stabilized by the resonance. Therefore, what happened? Phenols are strong acid. Correct. Next, after this, what happened? The acidic character of what? Different phenols. If you observe different phenols, if you observe here. So, if you observe what happened, nitrophenol, orthonitro, metanitro, paranitro, everything we'll discuss now here. The acidic character in this slides now. Now you observe what happened. Do you have any resonance here? No resonance here. There is no resonance here. Here we are having resonance is possible. ये आपने हमें delocalization of negative charge, isn't it? Delocalization of negative charge. Next, these are all we discussed. This is about resonance. How the resonance will takes place. You observe here what happened. So this negative is shifting over where? Here like this. You can write like this, shifting like this, and this will come. Otherwise, you take a pen like this and draw this one like this. O minus, first of all, you write O minus here. Now, this negative is shifted over here. The double bond character now convert into negative like this. And we got, here we get double bond O. and the pi bond will convert as a here negative character. Again, the negative will convert into pi bond. The pi bond will convert into negative. So we are going to get like this. Here a negative character, negative convert into pi bond, double bond. Again, negative will convert into pi bond will convert into negative. So because of this resonance, what happened? That molecule will get the stability. Because of these structures, what happened? It used its time for what actually? This type of migrations. So that is the reason it's highly stable. Now finally what happened? This will shift over here. So we are pi bond, here also pi bond, O minus. Same phenoxide is getting. The first one and the last one, fifth one will be what? Always same only, isn't it? So because of this one, isn't it? Because of this what happened? So why I am explaining repeatedly? Because the question is important so that you can remember for long time. Now we see now here different phenols will have different acidic character. Okay, by substituting the remaining molecule there, here let me see that one also. Here let me see. Now I will write the molecules here. By taking one and everything, first one. The first one I am writing here, orthonitrophenol. How to write orthonitrophenol? First one. You write first of all phenol. Everyone knows the phenol. This is the phenol. Ortho means where you have to put here. Which group you have to put here? NO2. This is called what? Orthonitrophenol. Orthonitrophenol. Next one. Second one. Metanitrophenol. Metanitrophenol means where I have to write here. In examination, they don't give structures better. They will give only nomenclatures only. You have to write. You have to make like this. Paranitrophenol. Third one is what? Paranitrophenol. NO2. Okay. Then fourth one. Phenol. Simple phenol it is. Right? 4 molecules have taken. Now the fifth one, this one. Fifth one. Okay. The fifth one I am writing here. The fifth one I am writing cresol. Cresol means it looks like this. OH. Orthocresol, no. Put here what actually here. CS. Okay. Donating group. Simply what happened? Meta. Here something. Paracresol. Here something. And the fifth, sixth, seventh, eighth one, this one. Ethanol, you know this one, CS3, CH2. I have written all the molecules, right? Now, what is the question here? Which is having more acidic character? तो यहाँ पर आपको याद रखना है Ka is directly proportional to acidic character. Ka is directly proportional to acidic character. Whereas Pk is inversely proportional to acidic character. Pk is what? Reversely to what? Ka. So inversely proportional to what here? Acidic character. Now what I am saying here, higher the pKa, lower the acidic character. Correct or not, beta? Tell me. Higher the pKa, lower the acidic character. Lower the pKa, higher the acidic. Now tell me which is having highest acidic character among this box? Which is having highest acidic character, beta? Which one is having highest acidic character?
Oh, nitrophenol.
7.2 is the lowest pKa. Therefore, it will have highest acidic character. Orthonitrophenol is a stronger acid when you compare with metanitro and paranitro. But here, Ortho, para almost are same only. So in that case, what happened? There is no difference. So slightly it will difference. 7.1, 7.2, what happens? Slightly they are different. So because of what ortho is near, something what happened, the effect is very less, compared to very less it is. So generally, ortho and para almost all they are equal. Ortho and para, they're almost all equal actually. So para nitrophenol, ortho nitrophenol are having almost all same acidic character. If you have exactly what happened, little bit what para nitrophenol will be strong acid. Now, if you observe what happened, first, second, and third one, these three things are having strong acidic nature compared to remaining. Why? Because this is which type of group? Electron withdrawing group. Electron withdrawing group. Electron, this part. Electron withdrawing group. So presence of electron withdrawing groups, just now I told you, electron donating groups, releasing groups decreases the acidic character, where electron withdrawing groups will increase the acidic character. Now, which is strong acid? Whichever the groups having electron withdrawing groups, the phenol which are having electron withdrawing groups, the strong acid. Now, in the case of fourth one, if you observe the phenol, phenol is not having neither इलेक्ट्रॉन विथड्राइंग ग्रुप नॉर डोनेटिंग ग्रुप. यहाँ पर आपको कुछ भी नहीं है. You don't have any type of groups here. On this one, phenol, no withdrawing, no releasing. Therefore, it is in the middle case. Now, cresol, if you observe, donating groups. These are actually what? Donating groups. Donating group, donating group, donating. So, presence of electron donating groups, isn't it? Decreases the acidic character. That is the reason these are having what? Less acidic character, because they are having what actually? Electron donating groups. These are having what actually? Electron withdrawing groups. And this is not having nor electron withdrawing group nor electron donating. दोनों नहीं यहाँ पर. Both are not there actually. But ethanol actually alcohol. Ethanol is alcohol. So generally alcohols are less acidic than the phenol. Okay, so I am writing here what I am writing here. Simple thing. Okay, electron withdrawing groups more acidic than phenol, and electron donating groups. Okay, these are also phenols only. These are also what? Phenols only. Okay, this order, if you remember what happened, we can write anything actually. Now this is a question, example 11.4. ये आपको लिख सकते हैं ना, ये कर सकते हैं ना. Don't write like this here. All of you write with structures. I will see here. One more thing. More electron withdrawing groups, more acidic character. Now you observe here what happened. This is alcohol. You write like this in the notebook. You write this is alcohol. Then only you can practice like that. If you practice, it will be easy for you. Don't do write whatever is there in the text. Don't write like that. You have to study that one. Alcohol. Now methyl, electron donating group. Electron donating group. Next, phenol, neither electron donating group nor withdrawing group, comes in middle. Nitro, electron withdrawing groups. 3,5 dinitro, 2 electron withdrawing groups. 2 electron withdrawing groups. Now trinitro, 3 electron withdrawing groups. Now it will be very simple. Now which is strong acid here? 3 electron withdrawing groups. Next 2 electron withdrawing groups. Next 1 electron withdrawing group. Next phenol. Next what happened? Electron donating group. Finally what happened? Alcohol. Completed answer. So no need to add anything here. Correct or not? Any doubts you're having in this question? Anybody having doubt here? Tell me now. 11.4. Are you having any doubts here?
No, sir.
Simple or not? So what you have to see? First alcohol. Okay, then electron donating groups. So then phenol. Then electron withdrawing groups. As number of electron withdrawing groups are increasing, acidic character also increases. So after this class, write the structures like this. For this question, write the structures and order, increasing order you write. Right, increasing order, right? So this is very important one. So practice this one. ये आप कर सकते हैं. Give two reactions. 11.14. Give two reactions that show acidic nature of phenol. Compare acidity of phenols with that of ethanol. Isn't it? कर सकते हैं ना? सोडियम हाइड्रोक्साइड 11.14 यहां पर है ना, सोडियम हाइड्रोक्साइड ऊपर है, यहां पर है, ये रिएक्शंस आपको करना है, यहां पर है ये रिएक्शन सोडियम हाइड्रोक्साइड यहां पर दिया ना, sodium hydroxide and sodium. With this we have to write these reactions. You have to write. Next, explain why orthonitrophenol is more acidic than the orthomethoxyphenol. ये क्वेश्चन है. orthomethoxyphenol आपको क्या लिखते? Nitrophenol, which group it is? Electron withdrawing groups. Methoxy group is what actually? Electron donating. So in the methoxyphenol, presence of electron donating group less acidic. In orthonitrophenol, presence of electron withdrawing group more acidic. है ना? Right. Next, ये आपको बाद में आएगा. Explain how OH group is benzene. Okay. Right. We'll move to what next one? Next reaction now. Yeah. Esterification reaction. Very, very important reaction. It is esterification reaction. Let me see now esterification reaction. Now, what is the meaning of esterification reaction? The reaction between the alcohols or phenols with carboxylic acids is called what? Esterification. In addition to carboxylic acid, you can take acid chlorides, acid anhydrides also, you can take that one. So the reaction between alcohols or phenols with what carboxylic acids are called esterification reaction. I'm writing a reaction here. The first one I'm writing here. The first one here I'm writing. All of you please observe here. Phenol I'm taking. Aromatic means phenol. This is the phenol. Right? Next. Reacting with what here? Shall I write reversely? I will write. Better to write reverse here. I will write in the reverse manner. First of all, write carboxylic acid. R place. Shall I take CS3 here? CS3 COOH plus. Take the alcohol reversely. You take this one as a reversely better. Take reversely. HOR. Okay. Then R means you can take CS3 whatever it may be. Okay. Now what you can here also you can take R also. R means आपको पता है ना R. मैं यहाँ पर भी R लिखता हूँ क्योंकि आपको कंफ्यूज नहीं हो. R लिखो यहाँ पर R डैश लिखो. R डैश लिखो. तो आपको क्या होगा यहाँ पर OH minus H plus आपको निकालना है. Now remove this one. Then you get what R CO. Remaining is what actually OR dash. This is called what ester. This is called what ester. So this reaction is called what esterification reaction. Esterification reaction. The reaction between alcohols and carboxylic acid to give ester is called esterification. The same reaction we can also get from where? With phenol also. With phenol also we'll get same thing. Same thing we get with phenols also. I've taken here phenol. Same thing. OH and hydrogen is removed. Now what we are going to get here? R CO O phenyl group. In this way we are going to get it. So what is esterification? The reaction of phenols or alcohols with what carboxylic acid is called what esterification reaction. The same reaction we can also will get from acid chlorides also. With acid chloride, for example, I can take some acid. Second one, third one, this one, third one. So let me take third one here. Acid chloride. Again, I'm writing acid chloride like RCOCl. RCOCl. Reacting with again what? Alcohol, HOR dash. Same thing. Again remove HCl here. In the previous case we removed water. Here we are removing HCl. Now what will be the remaining we are going to get? RCOOR dash we are getting. RCOOR dash we are getting. Ester we are getting. Ester. Okay. Similarly, what happened? You can take acidic anhydride also. Second one is acidic anhydride also we can take. You take what this example again, acidic anhydride. RCO. I'm writing like this. Again, O, C double bond O R. Okay, this part I have written like this. This part. RCO, O, CO. This RCO taken how many times? RCO taken 2 times and oxygen. Reacting with what again? Alcohol. R dash. तो आपको क्या लिखना है यहाँ पर? RC double bond O and what happen? OR dash. ऐसा लेना है आपको. यहाँ पर भी आपको सेम आएगा. क्या आएगा आपको? RC double bond O OR dash. Ester आ रहा है ना? So 3 reactions are there in which alcohols or phenols react with carboxylic acid or acidic anhydrides or acid chlorides. यहाँ पर है acidic anhydrides and acid chlorides. Acid chlorides, acidic anhydride. This acid chloride is given here, third one. This is what? First one. This one is the second. You observe here, it will be there. Understood here? Now here, if you observe here, a famous reaction called aspirin preparation method. Preparation of aspirin. Aspirin कहाँ लेते बेटा? Do you know? Aspirin medicine. कहाँ लेते aspirin? Where we take aspirin?
For sleeping.
For acidity.
अब सभी ने लिया स्लीपिंग के लिए. अभी स्लीपिंग के लिए नहीं लेते, वहां पर किससे लेते हैं? एस्पिरिन. हार्ट अटैक. To reduce the fat content, heart attacks what happen? We'll take aspirin. Okay, तो aspirin कैसे प्रिपेयर करते हैं एक बार देखना है. So this is phenol or not? Just observe this one. Is it phenol or not? This part is phenol or not? This part. This part is phenol. Carboxylic acid is there, but anyhow take as a phenol part because we have to react. Phenol is reacting with what? Acidic anhydride. So this is generally called salicylic acid, but it has phenol part. It has a phenol part. The reaction is called salicylic acid. The name is called salicylic acid. Now here, phenol part. Right. Next, acidic anhydride. Again, this part I am writing here. CH3, C double bond O, C double bond O, CS. Now what happens here actually? Just same reaction. How to make the reaction? This you need to remove. This part you have to remove. Okay. Now this part you have to add. This part you have to add. Same, just now what we discussed, same thing. तो आपको ये आएगा. This will come. Okay. Otherwise, I am again drawing this. COOH same. Here no change here. So what we are getting? Oxygen, and this part will come no. C double bond O CS3. It is called aspirin. Acetyl salicylic acid. Orthoacetyl salicylic acid. Because this is acetyl, this is salicylic acid. So ortho or acetyl salicylic acid. The preparation of aspirin is also very important. So how we get aspirin? Which reaction is taking place in preparation of aspirin? Which name reaction is taking place here? Esterification. Esterification is taking place here. Now here something is given when you take especially acid anhydrides. So in that case, what we have to take? Pyridine we have to take because that neutralizes the HCl which is formed during the reaction. So you take what? Pyridine in this case. Okay, this is only the thing. Now one more thing, very important one. Here it is. So here what is happening here? Acetylation is taking place on which element? On carbon or oxygen? On oxygen, no? So here acetyl group is adding on oxygen, that means on alcohol in phenol. Now the reaction is called acetylation. O-acetylation also we can. O-acetylation also we can. This reaction is also called O acetylation. Why O acetylation? Because on oxygen here, on oxygen, which group is adding here? Acetyl group is adding here. Acetyl group is adding this group. On oxygen, in the place of hydrogen on oxygen, in the place of hydrogen on the oxygen, acetyl group is what adding here, introducing here. Therefore, it is called acetylation reaction also. O acetylation reaction we can call it. Okay. Next, we'll see the next 5 minutes. We'll complete this one. This already we have done. Anyhow, again we'll do this one. This first and second part already we have done the in the where halogen compounds. In the last chapter, Lucas reagent. We have done that. Lucas test. We'll do now Lucas test. Okay, and reaction with PCl3, PCl5 already we have done. So this you have to PCl3 and PCl5. You have to take from the halogen compound. I will just complete the first one. Second one already we have done in the last chapter. Let me see that one actually. Now we'll do one thing here. Now here, what I am doing here, if I take alkyl halide RX, I have taken alkyl halide RX. I have taken X equal to what we can take here, chlorine or bromine, right? Now this is reacting with what actually HX, reacting with HX. Okay, sorry, this is OH. No, sorry, just a minute. This is alcohol, sorry. This one is alcohol. Okay, sorry. Here X equal to chlorine or bromine. Here this X is equal to what actually? Chlorine or bromine. This is alcohol. Only alcohols will react, not phenols. Remember. Now what happened? Water will be removed here. Water is removing. X is attacking here. So we are getting alkyl halides here. We are getting alkyl halide. Now it looks, if I same thing what happened, if I take a reaction like this, I have taken something what? A primary alcohol, RCH2OH I have taken. This is a which type of alcohol? Primary alcohol. Now reacting with what? HCl. In presence of anhydrous zinc chloride. Anhydrous zinc chloride is called what type of reagent beta? Anhydrous zinc chloride is called what type of reagent? Yes?
Lucas reagent.
Lucas reagent.
Lucas.
So when I treat with Lucas reagent, primary alcohol, RCH2, isn't it? Cl is forming, plus water is forming. Plus water is forming. If I take secondary alcohol, RCHOH. This one is secondary alcohol. Same reagent I have taken. That is nothing but what? Lucas reagent. Here also I got what happened, RCH, RCl it is. It was a secondary one. And finally, if I take tertiary alcohol, ROH. Again reacting with Lucas reagent. We got something like this, RCl. Now this is tertiary. So in this case, these products will give some turbidity. Some type of turbidity it will form. And if I take primary, this turbidity does not form. Okay, slowly it will form. Take something what happened, half an hour, 30 minutes just take. For completion of this reaction, how much time is required? 30 minutes. 30 minutes it is required. If it's secondary alcohol, it takes some 5 to 10 minutes. Within 5 to 10 minutes, the reaction is giving turbidity. If it is tertiary alcohol, the reaction taking place readily. Immediately what happened? The reaction is taking place. That means we can distinguish. If I give you some alcohol, tell me which is tertiary, secondary, primary. How do you distinguish that one? By using Lucas reagent. Somebody's added Lucas reagent, immediately got turbidity. You can say that is what tertiary alcohol. If somebody is doing what happened, but heating what happened, he got after 5 minutes, you can say it is secondary alcohol. If somebody is doing what is not at all getting, but on heating, after some time what happened, he got 30 minutes what happened, you can say what happened, it is primary. Generally, primaries are having very low reactivity. So I can say primary alcohols are less reactive than secondary than tertiary. Just here. So here, which will give readily what happened? tertiary alcohols readily will give Lucas test. So this is the main thing actually you have to study in this case. In this case, you have to see. In case of tertiary alcohols, the turbidity is produced immediately as they form halides easily. Primary alcohol, they do not produce turbidity at room temperature. They do not produce. On heating, it will produce. 30 minutes. It takes some time. So very, very important. आपको नोटबुक में लिखो लूकस टेस्ट लिखो बेटा लूकस टेस्ट लिखकर ये आपको लिखना है लूकस टेस्ट लिखकर क्या लिखते हैं आप प्राइमरी अल्कोहल्स does not give at room temperature. Secondary alcohols will give after 5 to 10 minutes. The tertiary alcohols immediately will give what? Turbidity will give you. Immediately it will give you. So understood the Lucas test, all of you practice this one. After this what happened, I have given already one reactions here. In alkyl halides, you see that one. Alcohol, ROH reacting with PCl3, ROH reacting with PCl5, ROH reacting with what here? SOCl2. All these reactions already I given to you, isn't it? So that is there in the halogen compounds. We write the products for this one. In the byproducts also we write this one. So this is about the today's class. So tomorrow we'll see the dehydration, which is also important mechanism is there. Dehydration mechanism we'll discuss, oxidation and phenols. Tomorrow we'll try to complete the phenols. Okay. Phenols we complete because tomorrow we'll get 1.5 hours. No, tomorrow I will try to complete this one up to here, up to Riemann-Tiemann reaction I will complete. So that next year onwards we start ethers. Okay. So all of you do that exercise, whatever I told you, that exercise you have to do compulsory. The in-text, whatever getting, we are discussing now. The exercise problems you have to do compulsory. That remaining exercise we get, no problem. So whatever I have given today, you complete that one. Okay, right. Any doubts you're having? How many presents are there? Only 36. Who are absent? Let me see now. Who are absent now? This means including me that one. 34 only present. 6 members were absent today. Amruta. Just I'm reading the names here. Amruta, Anupama, Dhruv, Bhuvaneshwari, Deva, Hariom, Manjusha, Kiran, Neha M, Neha S, Nidhi, Nikita K, Nishant, Parth, Patiladarsh, Devashish, Pranali, Rani, Rohini, Samiksha, Samrin, Samruddhi, Shivani, Shreya, Paushe, Shreya, Sneha, Swapnali, Tejas, Vaishnavi SP, Vaishnavi VH, Vanita Prabhakar, Varsha, Venkatesh, Vinayak. तो दो एब्सेंट है ना, वैष्णवी बेलगांवकर एब्सेंट है और वैष्णवी के एब्सेंट है, वैष्णवी के भी एब्सेंट है आज. If you have doubts, you can stay with me. Otherwise, we can sign out from here.